In Module 3, we're going to talk about the APIC controller cluster. We're going to give you an introduction to the APIC controller cluster as well as an overview, how it works and how to assemble a cluster and different rules for how to make sure the cluster is highly available. Then we're going to talk about the installation of the APIC cluster as well as interacting with the web user interface and the NXOS style CLI.
Okay, let's introduce the APIC controller cluster. So the ACI goal is to have a common policy and operations framework. So whether you're doing application administration, security administration, and network administration, we're collapsing it into a single fabric and a single pool of resources that we can draw from. So whether we're doing layer 2 through 3 routing and switching, or we're doing things like service insertion of firewalls and load balancers, it's all done through ACI, and it's all done into the APIC controller. Now, the APIC is the policy controller. It's not the control plane and it's not the data plane. The control and data plane are on each individual node, each individual leaf and spine. So that's where the policy gets put into place. We define the policy into the APIC controller. It is a highly redundant cluster of 3 to 5 servers, and every piece of information in the APIC cluster is replicated 3 times. So traditionally, most of the time we're going to have 1, 3, or possibly 5, although usually it's just 3. Obviously, 1 is not going to be appropriate for a production environment, but there are lab bundles where you can get just 1 and you can use 1. You're going to see an error. It'll show up as an error saying, hey, you've only got 1 APIC node in your cluster. But you can't use that for lab environments or proof of concepts. For production, of course, we're going to want at least 3 because every piece of information is recorded 3 times. And you can go up to 5, although 5 is typically if you have a really large fabric with a lot of ports and a lot of changes being made. It is a highly redundant cluster, and they are all active. So unlike traditional controller architectures where we have something like an active standby, in ACI, everyone is active. Every node in the cluster gets its own IP address, and you can make changes to any of them at any given time. Every piece of information is replicated 3 times, even if you have 5 in your cluster. And so that way you can lose up to any 2 nodes in your cluster without having any data loss. So why 3? Well, a couple of reasons. One, there's a lot of new architectures. For example, if you're familiar with any of the scale-out storage architectures like Ceph, they're doing replications of at least 3 times, because that way we can check for a minority report. So take these 3 in a given cluster. So this is an APIC cluster. We have 3 servers here. If we have a piece of information that says 101, and then this one says 1010, and this one for the same piece of information says 1011. We compare them and we see that this is the minority report. These 2 report 1010, 1010, so these must be correct. As a result, this one gets thrown out and then we re-replicate. Also, every piece of information is split up and divided amongst these 3. So if we have and again, everything in ACI is an object. So if we have, for example, a configuration item, maybe this is a subnet that exists on a bridge domain, and its name is 10.10.10.0, belongs to, and the subnet's going to have some definitions to it. It's going to belong to a bridge domain. It's going to belong to a VRF or context. It's going to belong to a tenant. All that information is stored in this piece of information, usually in XML, and then it's going to get replicated 3 times. Now, one of these replicas is going to be the primary replica. So let's put it over here. So this will be the primary replica for this piece of data. And then we have the secondaries and these 2 over here. So what does that mean? Well, if I do a login into this 3rd node here and I make a configuration change on that subnet, this node will proxy my change and send it to the appropriate node that has the primary replica. It will make the change and then replicate the change onto the standby, onto the secondaries. So for every piece of information, everything in an ACI is an object. The objects are distributed across the cluster. And so rather than have like a configuration database for all items that relate to tenants, we shard that information. So we split each piece of information up, and then we distribute it across the cluster. If we were to lose this node for whatever reason, then a new node would be elected the primary for that piece of information. And if we ever replace the node, then it would get replicated, and we might do a redistribution of which one's primary, which one's secondary, all with the intention of making sure that we can make calls to every one of the APIC nodes in the cluster. We're not going to overwrite each other. Every piece of information has a primary. Now, I said 3 to 5, so let's check some scenarios here why we have to have 3 or 5. In fact, in ACI, we want an odd number of nodes in the cluster as standard normal operating procedures. We can, of course, if we have a failure, end up with an even number, but primarily we want an odd number, typically 3 or 5 for redundancy. If we have 3, one of the things that can happen, so let's say we've got a simple ACI fabric here. We've got 3 APIC nodes. Here's 1, 2, and 3, all replicating, all active. Nodes 1 and 2 are plugged into these 2 leaves via VPC that's automatically configured. Node 3 here is also connected via VPC to these 2 leaves via automatically configured VPC. So let's say we have some sort of weird split in our network. We have a fiber cut that splits our network right down the middle. Now, we are still active. The entire fabric is active. Now, devices connected to this side can't connect here, communicate with devices on this side, and vice versa. But other than that, we're still forwarding traffic as we had defined in our policy. Over here, we can make changes. Why is that? Because we have the majority. We have a cluster of 3, and we have the majority of the members in the cluster. We have a quorum. So that means we can take action. Over here, this guy's running, and you could log into this one, and if you try to make a change, you would be denied. This one is in read-only mode because this one realizes that it doesn't have a quorum, doesn't have a majority of the nodes active, and this is to prevent this exact scenario where if we didn't do this and they were all taking writes, then now we've got some potential data corruption issues. So we can make changes over here. Everything's active over here, no problem. Over here, we are read-only. Once the network heals, let's say we repair oops, don't want to do that. See, we repair the fiber. Now, the cluster gets healed. This goes off a read-only status, and we're good to go. We can make calls. We can make API calls, GUI calls, CLI to any of these. Another scenario that might happen is if we lose. So let's say we lose these 2 APICs, and they're just gone. Maybe they were stolen. Now I'm running read-only. What do? Well, I've got a couple options. One thing I can do is in the configuration of this APIC, one thing I can actually make a change is I can actually remove these 2 from the cluster. Now I'm operating as a single node cluster, and now I can make changes. Obviously, this is not a redundant scenario. So what I'll do is I'll go to, let's say these are gone. They got stolen from the data center, and I'm never going to see them again. So what I'll do is I'll call up Cisco and say, hey, I had a theft, and I need 2 new ones. So you order 2 new ones, or maybe something bad happened to them. Maybe there was a hardware failure that affected both of them, and they're covered under SmartNet or something. Either way, so I get them, I plug them into just like I plugged in the other 2. They're going to come up, get IP addresses, and then we can join the cluster, and now we can build a cluster of 3 again. And everything's cool again. So we can still make changes to the network, and then once we get 2 more APICs in, then we can restore our network. What happens if we lose all of our APIC nodes? No problem. whatever policy we had instantiated is still game, is still working. It's just we can't make any changes to a given policy. You can back up your configurations, of course, so everything is backed up. One thing you'll want to do is encrypt your backup. It's a new feature that I think came out in 1.2 or 1.3. But if you do encrypt your backup, if you do a backup, make sure you encrypt it, because one of the things that happens when you encrypt your backup is it'll keep your passwords. If you do not encrypt your backup, all of your passwords go away. So you'll have to go in and log in as admin, and when you do a restore, and reset everyone's passwords. So something to keep in mind. Another scenario that you might run into is, so let's say you had some sort of failure. Actually, let's go back to a healthy cluster here. Oops, deleted too many things. So I'm back to a healthy cluster. Now let's say, again, we lose 2 APICs. Maybe they get stolen. And now I go into the manager, and I go into the APIC controller, and then I delete these 2 nodes from the cluster, and now I'm operating as a single node cluster. Again, not a good idea long term, but at least it gets me back into the game. And it's highly unlikely I'm going to lose 2 APICs, but if I do, then I'm still back in the game. Now let's say I look out in the dumpster and someone just dropped them off in the dumpster. So I've got 2 APICs. They are good to go. They were stolen, they were missing, but we've been found. One thing I'm going to want to do is I'm going to want to log into them without them plugged into the APIC cluster, or without them plugged into the fabric, and I'm going to wipe them. The reason why I want to wipe them is now these 2 by themselves are a quorum, and they can overrule this APIC here. I've already made changes on here, so now I'm out of time. I've got split brain in time. So what I'll do is I'll just wipe these guys. There's a command you can run to wipe them and reset them as if they were from the factory. I'll plug them into the fabric. I will initialize them. Oops, again, deleted too many things here. And then I will join them into the cluster as brand new nodes. Now, what happens, another thing that can happen is if you order 4, I've had a customer order 4 APIC controllers. What do you do with 4? Well, back to the original rules about having an odd number. I'm going to keep this one. I can power it up. I can give it an IP address. I can log into it, or I can sort of log into it, but it's not going to be part of the APIC cluster. You can't make changes on it. It doesn't have any information on it. Objects are replicated 3 times across our active members of the cluster, but not this 4th one right here. So this 4th one's kind of a ghost APIC controller. So, and let's say I lose this APIC controller. I can promote this guy. I can promote number 4. I can make that number 4 and add it to the cluster. I remove this one, so in case it ever comes back, we don't want its information anymore because it's out of date. Now I've got an APIC cluster of 3, and if this one comes back, or if I get a replacement, I'm going to wipe it, and it's going to be my new spare. So in ACI, we want an odd number, and right now 1, 3, and 5 are supported for normal operations. Well, 3 and 5 are supported for normal operations. 1 is supported if you're doing just a lab environment, but 4 is not a normal operating number. If you have 5, you can go to 4 if you lose 1, but normally we want to make sure we have traditionally operating, we want to have an odd number. And you can lose, even if you have 5, you can still lose 2. You can't lose 3 if you have 5, but you can lose 2 because every piece of information is replicated 3 times. So you can lose up to 2 nodes in any cluster without any data loss. All right, let's talk about the installation of the APIC controllers. So these are the C-Series servers. They are not ordered, again, they are not ordered as traditional C-Series servers. You can't just buy a C220 and then turn it into an APIC controller. These are purchased as specifically as APIC appliances. But they are, at their heart, C220 servers. So they have a couple of components, if you're familiar with that platform. So they've got the console port here. They've got the SIMC port, and they've got a pair of out-of-band management ports. They also have the VIC card. So this is where we plug into the ACI leaves, and an automatic port channel is created. Now, initially, these were just SFP plus interfaces, so you would have to have have a pair of leaves as as fiber. However, now the other VIC card is supported that has 10 gig base T. So if you have any of the 10 gig base T model leaves, you can plug into that as well. Just make sure you order the right VIC card or in the right configuration so that you can plug into your leaves. If you have a mismatch, for example, if you have copper ports on your APICs and you have only fiber ports on your leaves, then you can't actually stand up your APIC or your ACI environment. So connect to the console via a console port of CIMC, set the BIOS password. It depends on the configuration. It depends on the version, but every version has its own installation instructions, so make sure you follow those. So where to connect the APIC, like I mentioned before, this is the Cisco VIC card, virtual interface card, and then you plug one of these ports into one leaf and another port into another leaf, and an automatic port channel is created for you. And again, just make sure SFP plus ports are shown here, but they also have copper, 10 gig base T. The NIC properties are set for dedicated, and then the TPM, which is the Trusted Platform. I can't remember what the M stands for, but TPM is enabled. One thing to keep in mind, so when you start up the APIC console with the breakout cable, and you plug in your keyboard, video, mouse, and you'll see this as your initial startup script. So it's a lot like other Cisco startup scripts. So if you're familiar with the routers or, for example, the Fabric interconnects, they have their own startup script. So it's kind of the same thing here. So we enter the Fabric name. We give it the number of controllers in the Fabric. It says 1 to 16 here, but really 5 is the limit right now. Typically, in most production environments, we're going to have 3. Give it the name, give the controller, or give it the number. Which number in the cluster are we doing? Give it a name. You need to enter an address pool for the TEP addresses. So this should be this address space, this /16. I think the minimum for 2.0 is a /23. But this should not leave the ACI fabric. So these addresses are just the TEP addresses. These get assigned to each node, which are the leaves and the spines, as well as each APIC controller. So these should not be leaving the environment, so they won't get leaked out through it. This is a separate VRF, and they do not get leaked out to any external routing tables. The next is keep in mind, this is the VLAN ID for the infrastructure network. Now, the default is 4093. This is one of the reserved addresses in the Nexus 7K, 5K stack. So you may want to make it something different, such as 3967. So what do we use the infrastructure network for? If we have connectivity between the leafs and a hypervisor, either through OpFlex or through some other mechanism, such as AVS, which is OpFlex, or Hyper-V, then the control plane traffic from the leaf to the hypervisor runs over this infrastructure network. So if you plan on running AVS, or you think you might run AVS, or you're planning on running Hyper-V, or anything that uses OpFlex, you need to pick a specific VLAN ID. We recommend 3967 if you don't have any specific ones. This should not overlap with any other VLAN you're using on your network. So that's something to keep in mind. We do need an address pool for our BD multicast addresses, and then you can also set up dual stack now, so you can set up IPv4 or IPv6 or both. So the management network now supports IPv6. You configure the interfaces. Do you enforce strong passwords? Typically, you'll do yes, unless you'd like to live dangerously. and then type in the password. And after the first setup, then you can access the APIC via a URL or via the command line, or which is NXOS style now, or via a REST API. So switch nodes will have in-band access to infrastructure and management VRFs. They all have a management port out of band, as well as a serial console port. The recommendation, and this is true as of 2.0, I believe, is to use the out-of-band management ports for your out-of-band access. You can do in-band, and you can even do both. The issue there, however, is that if you do both in-band, out-of-band, in-band management addresses and out-of-band, it will prefer the in-band. A lot of shops are set up so that everything is connected through the out-of-band network. Things like NTP, which Cisco highly recommends you run, and so forth, are accessible via the out-of-band network. And on the leaves and spines, these are 1 gig ports that you can plug into. The APICs will have 2 attached to the fabric for data. So this is the VIC card right there. 2 for out-of-band management. So those are the other 2 gigabit interfaces you can plug into a 1 gig network. And then 1 console Ethernet port, which typically is used for direct laptop hookup. So connect the leaves to the spines to build the fabric. Each APIC to 2 leaves. The port channel is auto-configured, or the VPC. And then connect the out-of-band network. Connect the APIC and the switch nodes to dedicated management ports. Again, it's probably a good idea to use the out-of-band rather than the in-band. Again, you can use both, but if you do use both, it will prefer the in-band versus the out-of-band. And then once you're done with that, the APIC is ready for configuration and fabric startup. So the first thing that happens is the APIC bootstraps the configuration. We get the cluster name, the fabric name, and the TEP address space on the infrastructure VRF from the APIC. So that was part of the initial setup script. It will detect that it's connected to 1 or more leaves via LLDP. So that's the link level discovery protocol, similar to CDP, the Cisco Discovery Protocol. And request TEP addresses and boot file via DHCP. So the APIC is actually running a DHCP server. However, this is a DHCP server that is only used for the APIC and for the fabric infrastructure itself. So you can't use it for anything else. So once the first leaf is discovered, the leaf will start to discover that it's connected to multiple spines, and the spines will get their IP addresses via DHCP as well. And they discover that they're plugged into each other again through LLDP. Then the fabric will assemble. It will discover all the ports. You can plug, so on most of the leaves, in fact, all of the leaves that I'm familiar with, we have dedicated ports that are to be used for uplinks. So these are 40 gig or 100 gig ports that go up to our spines. It doesn't really matter how you plug them in. So you can mix and match. For example, if I do E11 to spine 1, and over here I do E14 to spine 1, that's okay. It doesn't have to have any rhyme or reason. We do need to have a fabric. We do need to have each leaf attached to each spine, at least with 1 connection. You can do asymmetric. So for example, I can do 2 connections to leaf to spine 1, and then just 1 connection to spine 2, 1 connection to spine 3, and 1 connection to spine 4. It's not generally recommended though. So generally recommended is that you have a consistent number of connections to each spine, or a similar number of connections to each spine. But then the ports you use don't really have to have any rhyme or reason to them, other than it's just a good idea to be consistent. But there are specific ports on each leaf that are marked as the uplink ports, and that typically has something to do with the ASICs that are plugged in to the switch on chips that are plugged into them. So the fabric will assemble, everything gets discovered through LDP, and then everyone gets its own TEP address. That's the tunnel endpoint address. So leaves and spines both get their own addresses. They're like loopback addresses. In fact, I think they are instantiated exactly as loopback addresses. And then a simple routing protocol is set up, IS-IS. It's a very basic routing setup, because all we need to do is have TEP address availability from one device to another. So it's a very static, very small network. So all nodes in the same APIC cluster should contain the same bootstrap information if they are intended to form a cluster. So that's pretty easy to do. And then the APIC cluster will form when members discover each other via the appliance vector. So that's something Cisco specific. And they will sense each other a lot like Highlanders and will build a cluster. And again, typically for the number of nodes in a cluster, you want 3 or 5, or maybe 1 if you're doing a lab environment, but we want an odd number. So the fabric initialization and maintenance node identity policy. So we assign an ID and name to switches based on their serial number. So how do we tell which is which in this scenario? Well, we use the serial numbers. So it's a good idea as you're racking and stacking these devices that you make a note of the individual serial numbers on them so that you can identify them when you're setting up the fabric membership. If you plug in let's say you get a new leaf, you plug it in via the 40 gig or 100 gig cable to the spines. It does not get automatically added to the fabric by default. So you'll have to go in, you'll have to select that new leaf or even that new spine. It's the same thing for spines. And you'll have to add it to the inventory, add it to the fabric. So it just doesn't, you can't just plug something in and it automatically works unless you configure a fabric initialization policy and you pre-populate that serial number. So once you get it in the loading dock, you take a note of the serial number, you put it in here, you pre-provision an ID number and a switch name, and then voila, as soon as you plug it in, it will get added to the fabric. But that does not happen by default. You can do the same thing via the API. It's under API node unique controller XML, and then here is the fields you plug in. It's shown as XML here, but JSON is also supported, of course. So the ACI fabric leverages the same global catalog methodology as UCS, supported hardware matrix, image versioning, etc. So when you're doing an upgrade of an ACI environment, and like any product, you're going to want to keep them updated on a regular basis. You don't need to update them every week, but generally I like to keep, personally, I like to keep something within 1 or 2 years of the latest release at the very least. So we have a couple of options. We create these policies that control how we upload the images. So let's say everything's running on 1.3 right now. So 1.3 is on the APIC controllers, 1.3 is on the leafs, and 1.3 is on the spines. You can create a group that has all spines, but typically you're not going to do that. You're going to create a group that has maybe your odd spines, and then a different group that has your even spines. So what you'll do is you'll upgrade your odd spines first. So they'll get shut down, they'll get rebooted, they'll load up with the new image. Then your even spines. Then the same thing with your leaves. We're going to upgrade your odd leaves first, then your even leaves first, and then one at a time we'll upgrade your APIC controllers. So it's very similar to UCS if you're familiar with that. We do these rolling upgrades which allow us to do a minimal impact upgrade. You'll still want to do this in a maintenance window, of course, but you should be able to forward traffic during the entire upgrade process. So at no point should, in most situations, as long as you've got enough leaves and spines, that you've got some redundancy, should you have any actual packet outage. You might be in a degraded state, you might be in a 50% forwarding capacity state, but if you do this during a maintenance window, that shouldn't be too much of a deal. But just like UCS, do check the documentation. So as a new version gets released and you want to update to that, follow the documentation. They may have different policies. They may have a different upgrade methodology. So there's a couple of different management networks in the ACI environment. We do have the infrastructure VRF. So this is used for in-band APIC to switch node communication. It is not routable outside the fabric. So whatever you use in the infrastructure VRF, you shouldn't have to worry about overlapping IP address space like TEP space. We do have the in-band management network, so that's a tenant VRF created for in-band access to switches, and we have the out-of-band management network, another VRF that the APICs and the leafs and spines use to connect to your out-of-band network right here. Best practice, typically we recommend at Lumos, we recommend people use the out-of-band network. Connect that to your NTP servers, connect that to your out-of-band network so you can access these different nodes individually. If you use both in-band and out-of-band, again, the in-band is the one that's preferred, and you might run into some trouble with the out-of-band network. And again, the infrastructure VRF is not routed outside of the ACI fabric and won't be route leaked out. So the web user interface, what you're seeing here is updated for the 2.0 interface. We have the main, we have the top level navigation, so that's the main navigation up here. We have system, tenants, fabric, virtual machine networking, layer 4 through 7 services, admin, and operations. We have a system dashboard. So go into system here, and we'll see the system health. Right, this screenshot doesn't show anything, but typically you see a graph with what the overall health of the system is. That's one of the big things to look at in the APIC GUI. Is we have a health score for just about everything. So if something has a health, if we have a health less than 100% or less than 99, we can start to drill down and figure out what is causing that. So most screens when the APIC are built on the navigation pane and the work pane style, very similar to other GUIs in the Cisco world. So on the left side we have the navigation pane, and on the right side we have the work pane, and up top we have the main navigation. So the navigation pane is on the left and allows navigation to all configuration elements given the tab on the top. So for example, we selected fabric. We have under fabric, we have 3 sub tabs here. We have inventory, fabric policies, and access policies. We've selected inventory, and we have all of the objects here that we can click on one of those triangles and then collapse it down. Once we select an object on the navigation pane, then on the work pane, then we see all the configuration options for that particular object. And then basic elements, everything is fairly hierarchical. For example, here we have tenants. We selected a tenant T01. We see that here under, we've got application profiles, we've got networking. Under networking, we've got our VRFs. Under different tenants, we can go to application profiles, create application profiles. So it's a hierarchical, it's folders and trees, context menu, workspace syncs with the navigation tree, and then consistency on right click on the tree and action buttons. So for example, if you right click an application profile, you'll see that create application profile button. So if you can create an object, just right click it and it'll show you how. A lot of the different aspects of the ACI GUI will have fabrics. One quick note about the GUI, it is HTML5 based. So Cisco, like a lot of other vendors, are running away from Java as their interface. UCS recently got rid of Java for its UCS manager. And ACI was built from the ground up to be HTML5. So no Java, no Flash. And that's an industry trend the industry over. So I'm very happy that we're not dealing with Java here. I think everyone can agree that that's a good thing. So under basic elements, under a lot of the elements, we might get a table here. So we have pagination controls. We can click on one of these columns and we can sort ascending, descending, edit the columns, etc. Sort and filter. Auto update. So the moment an object is actually updated, it will reflect on the screen there. So we're using WebSockets here. So if something changes, it automatically gets updated. You don't have to do a refresh. However, if you're not sure, if you think, well, you know what, maybe something should have been changed and maybe the refresh is broken for some reason, or maybe my browser is screwed up, you do have this refresh button right there, so you can manually refresh just for peace of mind. And then everything here can be downloaded via XML if you need to. So that's right there. So basic elements, we've got a consistent set of tabs for just about every configuration element. We have our dashboard. We'll show a historical representation of the health score. Right here, this screenshot doesn't show anything. Then we'll show fault counts by domain. So we'll have our severe and et cetera, different faults. System-wide access, external framework, infrastructure, etc. So if we have any faults, like right here, we've got 91 infrastructure faults. So typically that's misconfigured ports or something, but that's worth investigating and worth taking a look at. But they're not too severe, but they do roll up into the entire system. So for example, system-wide, we've got a health score of 91. Or we've got 91 faults there, and then they're all from the infrastructure side, and they're all the lowest alert there. So basic element properties, you can go to, so properties page always up to date, again WebSockets, although you can do that refresh for peace of mind. You can download an object via it shows up as XML. And then you can do actions here. So go to actions, for example, create application profile, create bridge domain, create VRF. Depends on where you're at as to what actions are available. But if there are any, you just click on actions and you can see what you've got. So basic elements, we have selectable properties and report interval. We've got a table or a graph view, and we can download everything as XML here. So we've got stats, general, etc. And then there's our overall health score. We can also break things down. For example, the overall system health is shown as 72. Well, why is that? Well, we can drill down and see our layer 1 physical infrastructure is at 90 health. Maybe we've got a couple of alerts in there. Look at this, LLDP entity is at 44 health. So there's a lot going on here that we need to unpack, so we can drill down into there as well. So if we just click that plus button, and we'd see another tree there. And then under history, so we've got like dashboard, policy, operational stats, health faults, and then we've got history. So we can take a look at the fault history. If we click on this right there under the faults tab, we may not see any faults at all. But we may have had a history of faults. Maybe something happened overnight. So we click on that, and then we can take a look at what's been happening overnight or happening over a period of time. Same thing for events. What has our health been looking like over a period of time? And then we have an audit log. Now, one thing to keep in mind when you're doing RBAC on ACI, just like with Cisco UCS and a lot of other systems as well, is that you'll typically have an admin account, and that has the administrator access to make changes to everything. It is not good practice. In fact, it's best practice even if you're only doing admin accounts. So even if the only accounts you're actually setting up on a system are admin accounts where they can do everything. So you have 3 staff members, and they're all granted full access to the entire fabric. It's still a good idea to give everyone their own individual account and not share the admin account. The reason is that audit log. So if something goes wrong, I can take a look at that audit log and see who made the change, who did what. If everyone logs in as admin, you don't typically have a lot of information, although it will record the source IP address of whoever did something. But if everyone's coming behind a NAT address, then that's not going to help you out much. So it's easy, and it's a good idea and best practice to give everyone their own account. And then even if you're giving everyone full admin access. And finally, as of 1.2, an NXOS style CLI was added to ACI. So like the GUI, it's a front end for the REST API. It provides a third configuration option. So we have the GUI, we have the REST API, and now we have a NXOS style CLI. You could use it in conjunction with the GUI and the REST API. Just because you do a configuration with one doesn't mean you're locked out of doing configurations with the other. And you can log into any active APIC node in the cluster to do this. And the configurations are synced automatically. One thing to keep a note you type in conf, not conft. If you type in conft, you'll get an error. So there's something to get used to. A lot of us are kind of, we have the muscle memory ingrained to type conft instead of conf, and it's kind of hard not to type conft, but you get used to it. And it's, again, it's an NXOS style. It's not NXOS, but it behaves a lot like NXOS. And a lot like NXOS and not like iOS. So there are subtle differences between iOS and NXOS. This mimics NXOS and not iOS. For example, if you're in config mode, you can just type in show run. You don't have to type in do show run. And then you can also use CIDR notation. So for example, IP addresses, rather than type out the subnet mask, you just type in the IP address and then / for the CIDR notation. So that's something to keep in mind. And it's useful. We used it a lot in our lab environments to do a quick eyeball of the configuration. And the GUI is great because it presents a lot of information. But the CLI is a little bit more efficient in terms of a quick overview of a configuration to look for kind of the usual suspects of why something is not working. But it's up to you. REST API, CLI, or the HTML5 based GUI, they all work just fine.